Test review. Converting radians to degrees. 180 degrees is the same thing as pi radians. What's the value of pi? 3.14. Okay? That is called our unit multiplier. If we are trying to turn something into degrees, then the degree measure is what goes in the numerator because we are trying to get rid of radians. So we're going to be canceling the radians. For instance, if you have 4 pi over 5 radians, and you were asked to turn this into degrees, find the corresponding angle measure that is 4 pi over 5 radians. Well, we're always going to use our unit multiplier with this 180 and pi. But since we're trying to turn it into degrees, we put that in the numerator, pi radians in the denominator. In this case, our pi's do cancel. Now on the test tomorrow, whenever you are turning it into an angle measure as degrees, you're going to use your calculator and you're going to round to the nearest whole number. Okay, so all you have to do from this point is put it in your calculator. 4 times 180 divided by 5, and that's a perfect number. It's 144 degrees. And I will have those instructions. Round to the nearest whole number. Okay?
So every time we just use the same.
You use the same one. If you're going into degrees, you always multiply by 180 degrees over pi. Always. Each one of these measures is in radians. Now notice in this one there's no pi afterward. But that's okay. It simply means it's a whole number. It's not multiplied by 3.14 yada yada. There is no degree symbol either. So for all three of these, you are converting from radians to degrees. In all three of them, the unit multiplier is exactly the same. You need to be taking notes. In every one of them, we're using the same unit multiplier because our goal is the same. Now in this first two, the value of pi actually cancels itself out. But in the last one, you have to plug that into your calculator. So because we're going to be finding degrees here and we're rounding to the nearest whole number, we're simply going to plug it into the calculator. 5 times 180 is 900. 900 divided by 2 is 450 degrees. You need to make sure you put your degree symbol. 17 times 180 divided by 5 is 612 degrees. 4 times 180 divided by, use your pi symbol, and we're rounding to the nearest whole number, so 229 degrees. Any questions on converting from radians to degrees? 4 times 180 divided by pi. Now, divide that by pi. Okay, you didn't finish it off. All right, when you're converting from degrees to radians, notice the two elements of the unit multiplier are still pi and 180 degrees. They're just flip-flopped. And that's because now our goal is to turn it into radians and get out of degrees. So whatever I'm trying to get into goes in the numerator. Whatever I'm trying to get out of is in the denominator, so it will cancel. For instance, if you have 750 degrees, and I am asking you to turn that into radians. You want degrees to cancel. Now in this case, you're going to actually leave it in fraction form, and you need to make sure that you can reduce. All right? Very simply, if your two numbers both end in 0, they can both be divided by 10. You've already reduced them by hundreds. Okay? 75 and 18. What's the rule about seeing if numbers are divisible by 3? If you add up the digits, and what you get is divisible by 3. If 7 plus 5, which is 12, is divisible by 3, then 75 is divisible by 3. If 1 plus 8, which is 9, can be divided by 3, then 18 can be divided by 3. Both of these are divisible by 3, so you get 25 pi over 6 in this case. If you have even numbers, they're divisible by 2. If the last two digits of your number can be divided by 4, then the whole number can be divided by 4. If a number ends in 5 or 0, or 5s and zeros, they can be divided by 5, right? Keys to help you remember. All right, these three are in degrees, and we want to turn them into radians.
Excuse me, this is Sally.
Yes, ma'am.
Hi, do you have Ryan Domain?
I do.
He needs to move his vehicle immediately. He's in the way.
Okay.
Thank you.
All right. Where'd you park?
Take your time. I don't know, like right on the side of the playground.
I wonder what you need to wait for.
Construction. Yeah, but how is it?
The bus already left.
That's probably the construction guys.
Maybe so. Oh, look, I just did 750. Huh. Can 7 and 18 be reduced by anything? No. All right, so this first one is 7 pi over 18. Can 13 and 18 be reduced by anything? No, so this is negative 13 pi over 18. And we just did this one. All right, any questions on this conversion? All right, you will be doing this tomorrow. You will also be asked to graph angles. They will be given in either degree measure or in radian measure. If it's given in radian measure, you can convert it to degrees and then graph it.
We have to know that chart.
No, it's going to be like that's going to be on the test for you to be able to graph. Okay? So you will see something like this, and next to it, it will say graph a 140 degree angle. Well, if you're going to graph a 140 degree angle, the first thing is, where do we always start from?
0, 0.
This is always our initial side, or our starting point for our angle. From there, if we're going to 140 degrees, we go past 30, 45, 60, 90, 120, 135. Now look, don't just stick it right smack in the middle of 135 and 150. Is 140 right smack dab in the middle of those two? What's it closer to? It's closer to 135, okay? So this would be about 140, this would be about 145, and that would be about 150, right?
Yes.
So here,